In the quiet coastal waters of Quahina Keel, Costa Rica, a subtle but profound disruption is unfolding beneath the waves. My research delves into those waters to address a growing concern: how artificial light at night can disrupt delicate marine processes, including those conducted by zooplankton. Zooplankton are tiny marine organisms which play a largely unrecognized role in mitigating the impact of anthropogenic CO2 emissions. Every night, zooplankton undergo the largest daily migration of biomass on the planet, ascending through the ocean depths in a vital process known as diel vertical migration. Darkness is the trigger for this migration, resulting in greater upward swimming behavior by zooplankton at night. By using the absence of daylight as a tool to remain inconspicuous, zooplankton are trying their best to avoid predation in the same way that you try your best to avoid public speaking. My research focuses specifically on copepods, small crustaceans that form a substantial part of the zooplankton community. When copepods move upwards at night to feed on phytoplankton in the surface layer, they are in turn preyed upon by fish and larger zooplankton. Those lucky enough to survive the night play a vital role in the transport of organic carbon back to depth, where it is then buried in sediments. This process effectively transports carbon originally present as atmospheric CO2 to the seafloor and is termed the biological carbon pump. So tonight, while you're all migrating downtown for college night, zooplankton are migrating upwards in the water column to aid the ocean in absorbing 30% of human CO2 emissions, which significantly dampens the impacts of climate change. This, of course, is almost as important as taking tequila shots and riding the party bus to EOS. To analyze the effect of artificial light on nightly copepod migration, I conducted plankton tows at two sites in Quahina Keel. My result on the left shows data from the offshore island Bajo Rojo, which is void of artificial light. Here, significantly more copepods were measured in the surface layer than at the bottom. This aligns with normal DVM activity by copepods at that site. In stark contrast, the fishing dock, which is bathed in artificial light, exhibited very low copepod abundance in the surface waters at night. This result indicates a decrease in DVM activity. Overall, this data suggests that artificial light at night suppresses the diel vertical migration of copepods in Quahina Keel, Costa Rica. The study directly shines a light on the global responsibility we bear in considering the environmental costs of future developments along our coastlines. By mitigating our impact, we can safeguard marine ecosystems, ensuring their vitality for generations to come. Thank you.